Hello, my math wizards! Welcome to Easy Math Concepts. This is Teacher Jem. Today, our topic is about finding the least common multiple or LCM. I will illustrate the use of the listing method and the prime factorization method in obtaining the least common multiple or LCM. Let's start with the definition of multiple. A multiple is a number that can be divided by another number without leaving a remainder. It is also defined as the product of a given number multiplied by another number. Let's have an example. What are the multiples of 3? In 3 times 6 is equal to 18 and 3 times 8 is equal to 24. 18 and 24 are products of 3. Hence, 18 and 24 are multiples of 3. Still confused, my math wizards? Well, what about counting by threes? Like 3, 6, 9, 12, 15. These are all multiples of 3. Also, remember your table of multiplications when you were asked to memorize your table of 3? So all the products there are all multiples of 3. Least common multiple, lowest common multiple, least common divisor. They all refer to the same mathematical concept and they mean one and the same thing. Steps in getting the LCM of two or more numbers. Number 1, list the first few multiples of the given numbers. Second, look for multiples common to the given numbers. Finally, choose the lowest common multiple or LCM. Let's find the LCM of 4 and 6 using the listing method. Let's write down 4 and 6. Let's start with 4. So the multiples of 4 are 4, 8, 12, 16, 20, until 36. Anyway, we can just extend the number later if we still can't find the common multiple. Let's now move on to 6. The multiples of 6 are 6, 12, 18, 24, 30, 36, and so on. Let's now look for multiples that are common to 4 and 6. We have 12. We also have 24, and we have 36. We have found 3 common multiples, 12, 24, and 36. But remember, we are looking for the least common multiple. So the LCM should be 12. Because 12 is the lowest of the 3. In the second problem, we will be finding the LCM of 4 and 6 through the prime factorization method. Here are the steps in finding the LCM of 4 and 6. In finding the LCM using the prime factorization method, we need to break down 4 and 6 into their prime factors. I'll be using the factor tree method as a visual tool to help illustrate the process of prime factorization. Next, list all the prime factors of 4 and 6. Last, multiply the prime factors to get the LCM. Before we proceed, let's have a quick review about prime numbers. Numbers can be classified according to the number of factors they have, and these are prime numbers and composite numbers. Prime numbers have only one and itself as factors, whereas composite numbers have more than 2 factors. Example, the factors of 2 are 1 and 2, and the factors of 4 are 1, 4, and 2. Prime numbers are natural numbers bigger than 1. Hence, 1 is not a prime number. In that case, 2 is the smallest prime number. And 2 is the only even prime number. All the rest are odd numbers. Examples of prime numbers are 2, 3, 5, 7, 11, and so on. Let's continue with the problem. Let's write down 4 and 6. As I mentioned earlier, I will use the factor tree method to illustrate the process of prime factorization. The factors of 4 are 2 times 2. We stop right here because 2 is already a prime number and we can't break it down any further. Let's encircle the prime numbers. Let's move on to 6. 2 times 3 is equal to 6. We stop right here because 2 and 3 are already prime numbers. Let's encircle the prime factors. After breaking down 4 and 6 into their prime factors, we list their prime factors in columns next to them. So let's write down 4 and 6 again. Now, let's write these two factors of 4 here, opposite 4. When performing prime factorization, it's important to organize the prime factors neatly in columns where each distinct prime factor gets its own column. But you don't necessarily have to draw columns like this. It's enough to align the prime factors vertically into columns. Now, let's write down the prime factors of 6 opposite the number 6. If you notice, we wrote 3 in another distinct column. It's because we don't merge different numbers in a single column. In short, 2 and 3 should not fall in the same column. Arranging the prime factors in columns will enable us to spot the prime factors that are common to 4 and 6. In each column, we only bring down one prime factor to avoid duplication or redundancy. So here goes. Let's bring down 2 and 2 again and 3. To get the LCM, we will multiply all the factors of 4 and 6. So 2 times 2 times 3 equals 4 times 3 equals 12. So the LCM of 4 and 3 is 12. To check our answer, let's compare it with our answer using the listing method. Regardless of the method used in finding the LCM, the answer should be the same. Let's find the LCM of 12 and 18. Using both the listing method and the prime factorization method. Let's do the listing method first. Let's write 12 and 18. Let's start with 12. Let's list a few multiples of 12 first. Let's have 12, 24, 36, 48. Now, let's list a few multiples of 18. So we have 18, 36. Let's stop at 36. Because we already have a multiple common to both 12 and 18, and that is 36. So the LCM of 12 and 18 is 36. Let's now find the LCM of 12 and 18 using the prime factorization method. Let's write down 12 and 18. Here, we will use the factor tree method in order to break down 12 and 18 into their prime factors. Let's start with 12. 2 times 6 is equal to 12. 2 is already a prime number and we cannot break it down any further. So let's encircle it. Next, 2 times 3 is equal to 6. 2 and 3 are already prime, so let's encircle them. So the factors of 12 are 2, 2, and 3. 12 is actually the product of its prime factors because if you multiply these numbers together, you will get 12. Let's now list down all the prime factors of 12. Let's proceed to 18. 2 times 9 is equal to 18. 2 is prime, so let's encircle 2. Next, let's factor 9. So 3 times 3 is equal to 9. 3 is prime, so let's encircle them. Let's list down the prime factors of 18. 2, 3, and 3. Let's now draw a horizontal line, and then let's bring down the prime factors. In this column, we can see that 2 is common to both 12 and 18. As a rule, we will only bring down one number to avoid duplication. This same principle applies with this column where 3 is common to both 12 and 18. Only one 3 is included in order to avoid duplication. To calculate the LCM of 12 and 18, we will get the product of all these prime factors. Actually, we can also express these numbers here in exponential form. Let's just count how many times 2 and 3 were repeated. So for 2 here, 1, 2. It's repeated twice. So instead of saying 2 times 2, you can just raise 2 to the power 2. The same principle applies with 3, so let's count how many 3's are there. 1, 2. So we can just raise 3 to the second power. Going back, the LCM of 12 and 18 is the product of their prime factors, 2 times 2 times 3 times 3. For easy computation, let's group the number by pairs. So 2 times 2 is equal to 4 and 3 times 3 is equal to 9. 4 times 9 is equal to 36. The LCM of 12 and 18 using the prime factorization method is 36. Regardless of the method used in finding the LCM of 12 and 18, computations should result to a final answer of 36. How was it, guys? Easy peasy, right? And to all my math wizards, I hope you find the content of my video valuable. Keep learning, because you're the real magic in the math world. Thank you for watching. See you next time.